Hi, sixth graders. We're back with another page of notes for this next topic, and so this is going to be page 3. Make sure you label page 3. And the title of this is going to be Reducing Fractions. Now, some of you may have heard of this topic before by instead of using the word reducing, sometimes the word simplifying is said. And so either one of those words is correct. Sometimes we'll call this reducing fractions, sometimes we'll call it simplifying it. The main purpose here is to make larger numbers smaller numbers so that we can do math with them easier. And so let's just jump right into what it means to reduce a fraction. So when we talk about reducing a fraction, what we really mean is we will divide both the numerator and denominator by a common factor to keep it equivalent. And normally we do this by finding a greatest common factor, or maybe what you have previously known as the GCF. Now, what is a GCF? Well, it's the largest. So a GCF is the largest factor that two numbers will have in common. And so, for example, let's look at the fraction 12 over 15. Now, you may think to yourself, well, 12 over 15 is not too bad. The number 12 is not too big. The number 15 is not too big. But if you're like me, I have a hard time with my 12 times tables. And also, I do not have my 15 times tables memorized. Now, maybe you do. But when we're doing math with these numbers, we want to try to make this fraction as small as possible and also by keeping the same ratio. So we've been talking about ratio the last couple of weeks, and we want to just make these numbers as small as possible while still maintaining equivalence. Now, equivalence just means two things are equal to each other. So, for example, what we might look at are the factors of 12 and also the factors of 15. So I'm going to draw a little line here as sort of a separator, and I'm going to look at what are the factors of 12 and what are the factors of 15. Maybe you have done this, some teachers will call it the rainbow method, but you don't necessarily have to draw a rainbow in. I just like going in and listing out, okay, we know that 1 and 12 are factors always, right? 1 in itself is always a factor. And then I can work my way in. Some teachers will have you draw in sort of a rainbow here and work your way inwards. If that helps you, fine. But 1 and 12 are factors. Now, does 2 divide 12? Well, yeah, it does. 2 times what is 12? 2 times 6 is 12. What about 3? Does 3 divide 12? Absolutely. 3 times 4 is 12. And so notice we have worked our way inward. Is there any number between 3 and 4? No. Those are all of our factors listed out of 12, the things that multiply together to get 12. Similarly, for 15, we would start maybe with 1 and 15. I'm not going to leave as much space because there's not as many factors. Now, before you write down a 2 here, does the number 2 divide 15? Well, no. 15 is not an even number, so we do not need to put 2 here. Will 3 divide 15? Absolutely. 3 times 5 is 15. The only number that is between 3 and 5 now is 4. Will 4 divide 15? Well, no, I don't need to write down 4 because 4 does not divide 15 evenly. Now what we look for is what is the largest number that will divide both of these numbers. And so I start looking for common factors. Well, 1 is common, 3 is common, and that's all, right? 1 is common, 3 is common, but which one of those is the greatest common factor? Well, the factor is 3. And so what I'm going to do is I'm going to be able to take 12/15 and I'm going to divide both the top and bottom by the number 3, because that is my greatest common factor. And when I do that, 12 divided by 3 is 4, of course. We established that up here. And 15 divided by 3 is 5. And so the ratio, or the fraction, 4/5 is equivalent to 12/15, only it has been reduced or simplified. I can deal with the numbers 4 and 5 much easier than 12 and 15. Now, if that is throwing you for a loop, think about it like this. What if I had 12 filled in dots? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I don't know. Think of those as like blue M&Ms maybe. And then what if I had 15 yellow M&Ms? Or I'm just going to make like an open dot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Would you agree with me that I have a ratio of 12 to 15? I'm comparing two things. 12 up here, 15 down here. Well, how do we know that's the same thing as 4 to 5? Well, it was by dividing it by 3, right? So if I take these M&Ms that I have here and I split them into 3 even groups by putting 4 in one group of the, the blue M&Ms up here and 5 in the bottom group, I evenly distribute these into 3 groups. There they are. And so count them and assure to yourself that yes, 4 for every 5 is actually the same thing as 12 total for 15 total. We just happen to divide it up into smaller groups so that our numbers are better to deal with. And so that is the premise of what we're doing when we're reducing or simplifying fractions, is we're making them smaller and easier to deal with. Let's try another example. So let's look at the fraction 10 over 40. All right, so think to yourself just a second. Do you know what the greatest common factor out of 10 and 40 is? Well, we could make a list like we did up here. We could come off to the side here and list out what are the factors of 10, 1 and 10, and 2 and 5. And we could think about 40, and we could list out 1 and 40, and 2 and 20, and 4 and 10, and actually 5 and 8, right? But hopefully you notice that both of these end in a 0, and so our list, let alone our knowledge of multiplication, should lead us to think that, 10 is the greatest common factor here, right? Because they both end in 0. My greatest common factor is going to be 10, and that's what my list says here. So I'm going to divide by 10. 10 divided by 10 is 1. 40 divided by 10 is 4. And I arrive at my answer of 1/4 because 10 was my greatest common factor. Now, what if you had done this problem and you had looked at 10 over 40? So I'm going to go over here, put a slash through my 2 lines here, and I'm going to do the same problem again, 10 over 40. But what if you had instead looked at those and said, oh wait, maybe you forgot about 10 as a factor. What if you thought, well, I know that both of these divide by 5, or maybe you even thought, well, 10 and 40 are both even, so I could divide them by 2 first. So let's actually try that. What if we do not use the greatest common factor? What if we just forgot about 10? And I looked at both 10 and 40 and I said, oh, those are even. They will both divide by 2. Well, let's see what happens. 10 divided by 2 is 5. And 40 divided by 2 is 20. Now, that, of course, does not give us 1/4. However, have we completely simplified? Is there something now that will divide 5 and 20? We divided it once here by 2, and it was a common factor. 2 just didn't happen to be the greatest common factor. So if I look at 5 and 20 now, after dividing by the common factor of 2, I can look at this and say, oh, well, 5 and 20, those can actually be simplified by 5. Both of those are multiples of 5, and 5 divided by 5 is 1, and 20 divided by 5 is 4, and we actually do end up in the same place again. So, as long as you have a common factor, it is fine if you have to do multiple steps. By using the greatest common factor, you ensure that you only have one step to do. But if you happen to, even just start with 2 and divide and find a ratio, make sure you double check and ask yourself, is my final answer here actually simplified, or do I need to take it a step further? And so, the moral of the story is that in the end, the reduced form of 10 to 40 is 1 to 4, or 10/40ths is 1/4. All right, let's try a couple of examples where maybe you pause the video and maybe you try this on your own. So let's do a couple of examples on your own. So let's try 3/9. Go ahead and pause the video and see if you can find a common factor that will divide both 3 and 9. I hope you pause the video. The common factor between 3 and 9, well, 3 only has 2 things that will divide it, 1 and 3, so it has to be 3. And again, if you needed to, come out here off to the side on a little scrap place and write out the factors, 1 and 3 for 3, and of course 9 is 1, 9, and then 3 times 3, so 3 ends up being your common factor. And if you divide 3 by 3, you get 1, and 9 divided by 3, you get 3. So my answer here is 1/3. All right, let's try this one. What about 6/24? Go ahead and see if you can find a common factor and pause the video. All right, I hope you paused the video. So for 6/24, we can think about the factors of 6. So I'm going to come over here off to the side and make my little list. So factors of 6 are 1 and 6, and then of course 2 times 3. And for 24, 24 actually has a lot of factors. There's 1, 24, there's 2 and 12, there's 3 and 8, and then there in the middle there's 4 and 4 times 6. So our greatest common factor actually ends up being 6. Now, maybe you thought about 2 first, and I'll walk through that again as well, but the greatest common factor is 6, and so if you can go ahead and divide by 6 on the top and the bottom, 6 divided by 6 is 1, 24 divided by 6 is 4, and so we get 1/4 here again. We've gotten a fourth a lot. But maybe you didn't think about 6 as the greatest common factor. Maybe you did it in 2 steps, and you divided by 2 first, and you got 24 divided by 2 is 12. But now 3/12 can also be simplified. All right, we can divide by 3 on the top and the bottom, and that still gives us 1/4. 12 divided by 3 is 4. So either way, you should have gotten down to 1/4. Let's do one last example. And let's try the numbers 18/20. So take a second and see if you can find a common factor there. So for 18/20, of course, we find that the only common factor that they have in common is 2. And if you needed to make your list off to the side, you would have again found that 2 was the greatest common factor. 18 divided by 2 is 9, and 20 divided by 2 is 10. And that is how you reduce or simplify fractions. So make sure you have all of that written down. Go back and pause the video if you need to. Make sure you have all those examples written down and out in front of you while you practice.